Okay, so I am back with the same problem, but now I'm going to show you how to solve it using some of our action keys, okay? So again, you already know how to solve this. Yay. So we're going to start with a new row, and we are still going to start with the same way, just looking for the antiderivative. So let's highlight that, copy, paste, and this time, okay. So this time, since we're going to use our action keys, we're going to highlight our integral. You have to, before you can use the action, you have to do something, right? So before there's an action, you have to do something. So you can't just go to your action first because it won't highlight or illuminate. So you have to click on something first and then go to your actions. And then you just start typing in what you want to do. So we want to do integration by parts. So integration, and then you look down, we have integration by parts. So here it actually, this is sort of what they call a subproblem. And so keep in mind, though, this is only finding the antiderivative. So we're going to have to go back to solve our original problem. But this is just, excuse me, finding the antiderivative, okay, by integration by parts. So notice here the notation is a little different here, too. So make sure that doesn't confuse you if you haven't used the action terms. It's a little different than what we're used to. U is the same. So U is going to be natural log of x. And then we just press the arrow. And then V, sometimes you have to press enter, okay? That's V prime, right? And so V prime, remember, V prime is dV over dx. So this is actually, you know, when we do our dV, we've multiplied the dx to the right-hand side. But V prime is dV over dx. So you're just looking at that expression and not carrying over the dx. And I hope I'm not confusing anyone, okay? So dV is just, or V prime, which is dV over dx, is just going to be x, because this is assuming we haven't multiplied by the dx to the right-hand side. Now, integration by parts, the way we do it in class, I like to do it with dV equals x times dx, but this is how Gradarius does it. So maybe for the future, we can give them that as a suggestion. Okay? Press enter or click out. Let's press enter. And it actually sets up. So your du, although you have to solve it. So it says, well, du of x is the derivative of natural log of x. Well, we already know the derivative of natural log of x is 1 over x, right? So again, what I mean is this dx is still over here. In our notes, we've already multiplied it to the other side, so it's 1 over x dx. So it's the same thing, it's just formatted a little differently, okay? And then the integral of x is going to be x squared over 2. And then here, don't forget your plus c, because it's not, this is just the antiderivative and not the definite integral. And so here it says apply integration by parts using the functions entered above. All right. So we already know. So that's going to be, again, x squared times natural log of x over 2 minus the integral, int, remember, of, I'm actually going to have our simplified version since we did this already, 1/2 x dx. All right, and then let's finish this antiderivative out. So that's minus 1/4 x squared plus c. And I think someone asked me about, it doesn't have to be a capital C. I'm just used to capital C's. It shouldn't matter. It shouldn't be case sensitive. So this is what I think Jayla was asking about in class. So this is because we did a sub problem. This isn't our final answer, right? Because this is a definite integral. And so we added to the result because it's the result of our sub problem, which was finding the antiderivative of x, natural log of x, right? So we add this to the result and we're done with just that portion, okay? So we're done with just integrating that, okay? And now we want to solve the definite integral. So we need a new row, right? Because there's nothing else that we want to write this equivalent, because now we want to bring in the bounds. All right, and so similar to what we did before, we copy and paste, and we use our evaluation symbol, Oh, did it click on it? There we go. And so we're evaluating from 1 to 2. Now, if you were doing this, because I know, but I think that homework closed, the homework with just the plain substitution where you do need to change your bounds, it actually does that for you too. With the action items actually can change your bounds for you too, to make sure, so you can sort of check with them if you use your action items to see if your bounds correct. But I want to show you this new action because I didn't talk about this in class, and I think it's a really cool action. I'm not for sure. You sort of have to play around to see when you can use it and when you can't use it, because it's not just going to help you solve the entire problem. But let's see what happens. So we want to evaluate this, right? Well, we're going to highlight. Well, let me get on that. Okay. Then we're going to highlight this. And so there's this action called try magic. And that basically will help you simplify your life. And you can also use, I don't know if you can use this to double check, sort of like a maple, but we'll talk about that later. So we highlight our expression and then we put try magic. And what do you know? We have our final answer, right? And so we just add this to the final answer, submit, and we are done. So I know